recording of the rest of the session. So
Okay.
yeah, welcome to the session, and please, Jianshuang, the screen is yours.
Yeah, thank you, Stephen, for the introduce. And exactly, I'm very, very happy to share my research in the past years on Tibetan Plateau about Alpine Grassland conservation. Exactly, today I want to share my experience. Since my PhD study, I wanted to let you know why I choose North Tibet as the research area, why I do research about Alpine grassland ecology and management. So the topic today will be Alpine grassland conservation in North Tibet or China. And I want to organize, I organized the slides in 5 parts: background, knowledge gaps we want to fill, and the current findings we published in the last years, and further research plan. And so the last will be the facts. So the reasons why we do research in the Tibetan autonomous region of China, as you know, is the third pole of our planet, and research findings in this plateau about grassland conservation may be helpful for grassland conservation in and high elevated areas globally. So this is the first reason I want to tell you. And the second is, as maybe you know or not, the Tibetan plateau are called Chinese tower of fresh water because several large rivers are sourced from this plateau. And it's very important for freshwater security for mainland China and South Asia. Yeah, so like the yellows from the Qinghai province and the Yangs also from the boundary between Tibet and the Qinghai province, and also the Indus and the Ganges and the Brahmaputra, and the Mekongs. So this is very important to do grassland research and also the grassland conservation actions funded by the governments. So the third one is why we choose North Tibet. North Tibet in locally also named as Jianshuang, it means a flat and high flat area in north of Lhasa. So this map from the World the Wildlife Conservation Society from a college from named Dr. Alicom, who led the Jianshuang project in about 2008. I joined his field work in 2009, and this area is the largest national natural reserve in China. It covers about 700,000 square kilometers. So it's the home of various animals and forests and in China, and also very rare plants. So this is a picture I shot it last in 2021 in summer in August, from the central Tibet. A small flock of male Tibetan antelopes are foraging on snow-covered steppes, and this is for Tibetan clans are running and grazing freely on steppes at the foot of snow-capped mountains. and also a herd of wild yaks are gathered at the front of the capital mountains, central North Tibet or central Jianshuang, and also a couple of black-necked cranes and their daughter in the upper meadows, dominated by Cabracea, yeah, and a family of Mamota. And so there are also other animals and birds and a lot of fresh and medical plants living in North Tibet in different meadows, steppes, and deserts. So, and the grassland conservation are also important for the local residents because the grassland provide food, milk. Yeah, it's very important for their food security and also for the livelihood sustainability for local herders. So in 2009, since my PhD studies, with the funding from my supervisor, Professor Shen and Professor Zhang, we set up a long-term research platform, including 9 or 15 pairs of fenced and grazed sites from meadows, steppes, and deserts across China. So this the field sites we conducted in the past 12 years from 2009 to 2020. So we were monitoring species composition and measure biomass, also some key functional traits at the species level. This long-term data allow me to do research about theory validation, also the policy making suggestions. So with this data, we want to fill the knowledge gaps about climate change and the rangeland management, livestock management, herders, livelihood, and also the policy making for grassland conservation. So this figure shows trends of climate change. About the red one are the temperatures. It shows it's rising at a rate about 2 times at the global average, and the green ones shows the trends of precipitation since 1980s. So this is the climate change, but in the map, we can see a significant warming happen in the central area, but a little bit moderate at the west and the south area. So this is climate change about temperature during plant growing seasons from May to September and yearly. So the next map shows us the special pattern of the changes in precipitation. So we can see clear in increasing precipitation in the east and northeast part of China, but in west and southeast part of China, the precipitation decreased, but not significantly. So this is about climate change. So how the traditional husbandry responds to changing climate in North Tibet? There are 3 figures show the different landscapes from meadows. There the herders kept yaks mostly, and in the central part is the steppe, and the herders kept shapes and growth, but in the deserts, they nearly only capture growth. So so we want to first we wanted to talk about the degradation of upper grasslands in North Tibet. Some review papers said that upper grassland in North Tibet have degraded about 10% of the area, partly due to changing climate, warming, or altered rainfalls and overgrazing. So the government wants to restore grasslands. So pilot program for returning grazed land to grassland started in 2004. From these figures, the green dots show the dynamic of livestock numbers at year end. We can see a drought since 2004. And the red one and the yellow one show the population and the meat production. So it's increased, are crazy in the last 2 decades. So the government built fences to restore degraded grasslands, and about between 2004 and 2012, about 3 million hectares of degraded grasslands are fenced and excluded from livestock grazing in Jianshuang, which contains about 16% of the.
Jianshuang, your voice has become very quiet.
Sorry?
Your voice has become very quiet.
Very quiet. No. It's not loud. Right?
Now it's better, thanks. Yes.
Okay, I will keep it a bit close to the microphone. So the question is how to now the question we are facing is how to disentangle and assess the relative contribution of climate change and human efforts in the recovery of degraded grasslands. So how to balance the economic and grasslands conservation. So we want to ask first if the short-term fencing are effective to improve or to restore the plant community structure. And the second, how does the grassland productivity respond to climate change and fencing? And the third one, how to understand the mechanistics under the recovery of grassland productivity. And fourth, what are the sensibility of upper grasslands in response to climate change in future, and what we should do in the next steps to manage or conserve the grassland in North Tibet. So the first finding is from my PhD thesis. This figures in the left shows the species diversity indexes responding to precipitation gradients. We found that short-term fencing didn't affect or didn't alert the manners of plant diversity in responding to climate gradients. So this means maybe short fencing doesn't work. So, and the figures in the right, which shows the species richness at functional group levels, verbs, grasses, legumes, etc. We didn't find difference between fenced and grazed plots, and the difference just appears between different grassland types. AM means Alpine meadows, DS means Alpine steppes, and it is desert steppes. So this means this figure tells us short-term fencing are not effective to affect plant community structures at functional levels. So the second is also from my PhD thesis. We compares the difference between fenced and the difference in biomass above ground between fenced and grazed size at different years. So these figures just show enhanced biomass about 25% compared to the grazed size, but this doesn't. It's hard to say fencing have positive effects because we do not have the data about livestock numbers or the grazing pressure because the biomass consumed by livestock is hard to access. So this is, but some difference are found between fenced and grazed size. And the figures in the right, we show the biomass ratio between forage plants and poisonous plants in their responding to the precipitation and temperature. We didn't find any change in the manner they responded to climate gradients. So this means it's still unclear how long we should fence the grassland for their recovery. So, and to use long-term data, we use remote sensing products and DVI as an indicator of productivity. We raised three hypotheses, and if the we calculated the difference and DVI between fenced and before fenced, and the baseline as the mean NDVI from 2001 to 2005, and the annual NDVI for the after fenced from 2006 to 2015. And we raised the three hypotheses. If the delta NDVI increased, maybe the grasslands are restored. And the second one, if the delta NDVI values dynamic around the equilibrium line, then maybe the effects, the fencing have no effects on recovery. And the third one, if the NDVI decreased, maybe the fenced grasslands is still on the way to degrade. So we use the generalized additive model. It allows to predict nonlinear questions. So we use
precipitation as the saucer, and also the temperature, and also the first years. The JED means grazing exploded duration. So this, when we use all the first areas, we can disentangle the effects of temperature and precipitation and fencing duration. So we can see in the meadows, NDVI increased, but in steep paths and desert steep paths, when the temperature is crowded, are reading if the warming more significant, maybe there are negative effects. So, and for the meadows, increased precipitation and have positive effects at all different grassland types. But the duration, we can see the cases from meadows supports the second hypothesis, and from the steep zones supports the first hypothesis. But in the desert steep path, maybe it's affected by partial rainfalls. So this is the analysis. We use different sensing products and first duration. So this is when we plot this result to the map, we can see there was no effects, no matter precipitation, temperature, or fencing duration has significant effects in deserts. But in the zone between precipitation between 200 and 400 millimeters, there are a lot of fenced areas affected by fencing grazing duration. So when we make a summary, we can see the fencing is the character F is fencing have effects, significant effects. Only 15% fenced areas or meadows have significantly affected by fencing, and only 22% fenced area in steep zone are affected by fencing, and in desert steep path there was no significant effects by fencing. So these findings have already reported to government for the policy updating. So now the fences has not has ceased to build in desert zones. So this is the third question we asked. So when we want to know how to botanically understand recovery, we measure the species and the functional trait diversity. We ask how the grassland productivity are regulated by diversity or trait diversity. We also calculated the productivity below ground, and also use generalized additive mixed model to use land use type and precipitation, temperature, and smoothers. We used the fenced area as reference and the grazed area as to control. So this figure just shows AMPP and BMPP responding to precipitation, temperature, and also the let's use effects on the manner how precipitation responds to climate gradients or precipitation and temperature. The line of zero is there was no different effects on the manner they responding to climate grassland gradients, but the BMPP was affected, especially in the area of precipitation between 2,250 millimeters and 400 millimeters. So this may be affected by the different functional groups because different plants have different biomass location between leaves, stems, and roots. So compared to the grazed communities, the short-term fencing just altered the manner of BMPP, but the AMPP vary around climate patterns. We also examined how if the land use types altered the manner of productivity location to the species diversities. So we didn't find any change between fenced and grazed size. So this findings just tell us short-term fencing has no effects on species diversity, productivity, and also have no effects on the grassland productivity in responding to climate and the shifts of land use between fenced and grazed. So this is the third question, but we just show a structure equation model to show the direct effects and indirect effects from climate variables from species diversity to productivity. So this just a little bit mechanistic understanding. So the further finding is about the functional traits, and you maybe know we use the isotopic combination of nitrogen between nitrogen 15th and nitrogen 14th to as plant functional traits of plants, and we compared the difference between the different grassland types and also the difference between functional groups. So we wanted to know how the grasslands structure and functional traits in response to the difference between grassland types and different land use types. So structural equation modeling just to tell us, yeah, the productivity can be regulated by the functional trace or as the topic computation of nitrogen. I sorry, due to the time, I don't want to talk about more details about the structural model because it's a little bit complicated. But this just give us an example. Functional trace regulated the recovery processes of upper grasslands, and the fourth is about how sensibility, how sensitive of upper grasslands to changing climate. We use our long-term data to predict species distribution. We use the random forest modeling, and this is a figure just to show the comparison between observed species richness and simulated by random forest modeling. And they match very well. So the random forest modeling can predict spatial distribution of species richness across upper grasslands. In this figure, we can see the precipitation in summer, how importance value about 10% is the highest, where it has the highest importance among the more than 10 predictors. So we simulated the changes in precipitation, how changes in precipitation affect plant species distribution, and we find the ecozone between upper meadows and upper steppes are more sensitive to changes in precipitation, and this is just to let the policymakers, the grassland in this area should be pay much more attention. So this is the source. We also use, as we talked about, functional trace can provide some understandings of the recovery processes, and the remote sensing products can be used to access at much more broader spatial scale. So we tried to link the access using remote sensing products and the understanding using functional trace. And for shrublands, also in the Tibetan Plateau, but in the north of the part, in the north part of the Tibetan Plateau, we use the remote sensing data to calculate the vegetation sensibility and this, and disentangled the contribution of temperature, precipitation, and drought on the vegetation dynamic or the vegetation variation. So this maps just shows the vegetation sensibility index and their contributions, and the structural equation models just show how the foliar functional trace, like the carbon content in leaves and nitrogen content in leaves. Also the soil nutrients, how these predictors affect the relative contribution of temperature, precipitation, and drought. And finally, to the vegetation sensibility index. So this is this finding is just published in remote sensing last year. So this means we can use remote sensing products for broad for assessment at broad scale, but we also should use field data to provide more mechanistic understandings. And the last question is how we should manage our livestock in response to climate change. So we use two meadows. The first one is the terrestrial ecosystem meadows. We use the vegetation, climate, and remote sensing data to predict potential productivity, noted as MPPP. And we also use a light use efficient model, CASM, and to predict actual productivity, noted as MPPP active. So the difference can be noted as the MPPPC. This means the biomass can be or potentially can be consumed by livestock. And we also calculated the biomass actually consumed by livestock. So this we use the number of livestock to estimate the forage update, and also use the meat sales to estimate the MPP meat consumed by livestock. So the difference between MPPC and the MPPC named MPP gap, and we use the MPP gap value of the MPP gap and its trend to guide livestock management. So this map just shows MPP values, and we find positive values or the values larger than 0. This means this area MPP or the biomass have a lot of biomass can be consumed, and the grasslands are not fully used for husbandry development. But in the west or southwest quarter, the MPP gap were negative or are smaller than 0. So this may be overgrazed and should be fenced or should be ceased grazing. And also some nested pastures with MPP gap value smaller than 0. So this is MPP gap is larger than 0. And the livestock capacity can be enhanced. So we also use estimate the MPP gap, the trends of MPP gap. So this area, the gap is also enlarged. So this means the capacity can be increased. So this is how we should manage livestock numbers. So for the further research plans, because now we have data about species or functional traits just for plants, we don't know more details about animals they kept, and we also don't know much about herders. So we want to shift the research frame from functional, just from the perspective of plants, to links functional traits between plants and animals. And also we wanted to link how the policy influence, how the policy for grassland conservation funded by government, livestock compensation, and then the interaction between the plant community and the livestock community, and also how this changes in plants and livestock affect grassland productivity, and finally how these factors affect herders' livelihoods. And certainly, we have already collected some data about the livestock diversity and livelihood diversification. And these bar maps, bar graphs, just to show the livestock composition and herd household levels, and from different counties, from meadow zones, from steppe zones, and desert zones. And this data also shows the livestock they saved for meat and all for income, and also the livestock numbers on hand at year end. This in the last 2 or 3 years, we have already conducted social surveys with face-to-face interviews with the head of about 1,000 households, and to collect data how they lived on grassland, and how many livestock, what kinds animals they have, and how many neighbors they have, and also the education levels. This allows us to link the plants diversity, livestock diversity, and livelihood diversification together to understand changes in environment. So last, we want to say thanks to the supervisors and colleagues, also from China, from Germany, and also my students. So before the last slides, I wanted to call for close cooperation between China and European grassland scientists, because we have the largest grassland area in the world. So, and exactly as Stephen said, we have already cooperation closely. We organized the conference, we organized webinar, and also online lectures. So let's cooperate closely in the future. Thanks for your attention. Any questions? Thank you.
Thank you very much, Jianshuang. That was a fascinating presentation. You've obviously done a huge amount of work there, and on a wide range of topics, very multidisciplinary. Do we have any questions for Jianshuang? I would like to ask one anyway. One of the topics you're interested in is conservation issues, but I'm interested to know about the like the rarer plant species. Are there any projects that are based on particular species or particular groups of species that are perceived to be in decline and need conservation?
Thank you, Steve. So you mean the specific actions for specialists?
Plant species.
Yeah.
Yeah.
So actually, there was no specific program, just returning grazed lands to grassland. But this program has already stopped in 2011 and replaced by a new program. It's called Payment for Alpine Grassland Conservation. For the fenced areas, the herder families will receive money from the government for their stopping grazing in degraded pastures.
Yeah.
And for the grazed area, the herders are also asked to reduce the grazing pressure under a nutritional level, and they can also get money from government as loans. So
yeah. So it's obviously a very different social and cultural context from what we see in European situations, I guess.
And exactly in the last year, this program also updated because the government adopted our suggestions, because as shown in the research findings, somewhere the fencing has no effects, and somewhere the fencing effects are positive, and some area are negative. So the money this received from the government also changed according to different effects.
Okay. Well, the next question is from Anke.
Yes, hi, my name is Anke Jentsch from Bayreuth University in Germany. I really appreciated your talk, especially this huge data set and large spatial extent and overview. That was very interesting, and all the details on vegetation dynamics. Now, in my team, there is Uji Neo, who's actually also online. Maybe you can also open your camera, Uji, if you like. Because we have a debate. He has been working on Cobresia grasslands, identifying all those interesting soil cracks that are forming. And there's this ongoing debate which role grazing or maybe overgrazing may play in forming those cracks, or whether it's more a near natural process. So what is your experience, or what is your idea? What is the current state of that debate as far as to your experience?
Thank you, Anke. Yeah, it's actually for the grading or overgrading. I have different opinion different from the review papers. In my view, especially in North Tibet, the grassland are not overgrazed, because during the last 10 years, I didn't find any changes, no matter in fenced plots or the grazed plots. And the grasslands are mainly affected by the dynamic or climate change, especially in precipitation. And I found the droughts have significant influence on Alpine meadows and steppes. In 2015, the grasslands in North Tibet suffered a serious drought, and the plants didn't turn green in August because the grazing season will end in September. So the plants just only 1 month to grow. So
would
drought might be more important.
Yeah,
like,
and it looks
climate extremes, not the overgrazing.
okay. Thank you. No, it's an interesting debate that we need to have more spatially differentiated information about to see which factor seems to be most crucial.
Yeah, exactly. This might be the difference between my research area and maybe the Dr. News, because I just focus on the grassland in northwest Tibet. And maybe it's different from the research from Qinghai province. It's quite different in grassland management and also in the restoration measures.
Agree. Until now, I think few research focus on the soil cracking. Because of that, I think in Tibetan Plateau, that's a very important issue, but only, I think, I'm not sure, but only several scientists focus on this topic. It's really a complicated issue because of related to the soil science and also vegetation, and also the overgrazing, and also I think many things related to the formation of the soil crack. So it's a natural process or a human-induced process. I think that's not easy to say yes or no.
I don't know how it is with plants, but with arthropods, there are several species which actually utilize those cracks. But I don't know if there are any plant species that benefit from them. Obviously, it must increase the heterogeneity at a very fine level, even though it's an indication of environmental problems. Okay, let's take the next question. Jürgen.
Well, many thanks for your very comprehensive talk. At the very beginning, you also showed some wild ungulates that are there in the Tibetan Plateau or used to be there. Could you say something which role in these grazing lands you showed or analyzed do the wild ungulates play still, or is there just where there is livestock grazing, there are none of these wild ungulates, or are they complementing the livestock, or how is the distribution and density of these wild ungulates in the grasslands?
So again, you mean the wildlife, the density of the wildlife?
Yeah. So what's the relative role of the wild ungulates compared to the livestock?
Okay, we do have data about the wildlife, but from my experience, because I traveled the area in the last case, I think the wildlife are increasing in the central Tibet, because that's in 2009, when I started my PhD studies in this area, it's hard to see wild yaks. But in 2021, I thought at least 10 small groups of wild yak. So this is just from my personal experience.
Okay, but it's still much less than the livestock grazing. So you put the ratios or the biomass utilization by livestock versus wild ungulate. So is it 10 times livestock to 1 times wild, or is it 100 to 1, or what is the ratio? just a gut feeling, so to have an idea which role these wild ungulates still play in the system.
It's very important to connect data about wildlife.
Jianshuang, your voice is very quiet again. Can you get the microphone nearer to your mouth?
Yeah, okay.
Yeah, that's better, thanks.
Sorry. Yeah, it's actually the wildlife are living in the central north part of this area, because this is the project region of wildlife conservation society, and the smaller part is the boundary of national nature reserve of China. This reserve are home to wild yaks, antelopes, hens, and also some rare birds. So this is the area wildlife most densest area. Yeah.
Yeah, thank you.
Thank you, Yugen.
Yeah, that's an interesting issue that I've also thought about. I wonder what the factors is that affect that. Are there some areas which are more accessible to herders for grazing? Are the protected areas, is grazing of domestic livestock completely excluded from those so that the wild ungulates can use that? Are there reasons like that which explain why some areas are heavily grazed and others are not?
Yeah, it's actually from this map you can also see there are thousands Alpine lakes. The blue blocks are the lakes in Chinatown. There are a lot of lakes, and the wildlife live nearby the lakes and the mountains area. Yeah, and this area is a little bit hard accessed by livestock, by other families. Okay, just the home to wildlife.
So there's maybe an advantage for the wild species that are adapted to inhospitable habitats that are less useful to the grazing.
Yeah.
Okay, any other questions? Okay, in that case, I'll switch the recording off now. So I'll stop the recording.